The next function we'd like to add to our repertoire to build the Laplace transform table is a ramp function. And the ramp function just looks like this. So it's a linear ramp that starts at time is equal to 0 and just increases linearly, in this case with just a unit slope. And so we're interested in applying the definition of a Laplace transform in order to figure out what the Laplace transform of this ramp function is. This is a little bit trickier, and you'll need to pull back something from your knowledge of calculus. So go ahead and give this a try. If you get stuck, go ahead and unpause, and I'll give you a hint, and then you can pause again and give it another shot before you look at the answer. So my hint here is that you'll likely need to use integration by parts. So look that back up and pause again and give it another try and see if you can get the solution. So as I mentioned, you're going to need to set this up and solve it using integration by parts. And the reason for that is because the integrand, now the function you want to take the Laplace transform of, and then the definition of the Laplace transform, produces an integrand that you don't have a basic integral for. And so the easiest way to solve this is to use integration by parts. And so again, this is the fact that the integral of u dv is equal to u times v evaluated at your limits of integration, and then subtract away the integral from a to b of v du. So in this case, you always want to choose the polynomial here to be the u term so that you get to take the derivative of it, and what happens there is that the du is then just dt. So now we've gotten rid of this polynomial term. The exponential term depends on what you want to accomplish, but in this case it's then the dv term, because you can go ahead and take the integral of that, and now you get this minus 1 over s that pops out in front of the exponential. So when you plug that into the integration by parts formula, you get this, and the only thing to remember is again that you're going to go ahead and evaluate this quantity at these limits. So oftentimes one, or even in this case both of those terms, go to 0. This term goes to 0 at infinity because of this term. It goes to 0 at 0 because of this term. And remember, the quantity that you're plugging in here is t is equal to 0 and t is equal to infinity. So then we're just left with this element, which is now able to be integrated directly, and we go ahead and get this term, which allows us to now understand that the Laplace transform of the ramp is 1 over s squared.